In this video, I'd like to do one example of using the elimination method to solve this system of equations, and this is going to be harder than the equations on the last video. If we take a look at the system of equations, you can see that we have to use the elimination method. It's not set up for substitution. If it was set up for substitution, one of the equations would say x equals or y equals, and I don't have that. Also, if I add these two equations together right now, nothing cancels out. If you add a negative 2x and a 3x, you get 1x. Doesn't eliminate. If you add a 5y and a 2y, you get 7y. Doesn't eliminate. So I have to make something eliminate. So take a look at the numbers that come before the x's. I see a 2 and a 3. I could turn a 2 and a 3 into a 6. I'd have to make one a negative 6, one of them a positive 6. If I look at the 5s and the 2s, the 5y and the 2y, I would have to change those into 10s. So I have a decision to make. Should I change things into 6s or should I change things into 10s? And usually people like to use smaller numbers. So I'm going to try to eliminate the x's, and that means I have to turn the negative 2x into a negative 6x, and I got to turn the 3x into a positive 6x, because then they would eliminate. So if I want to change the negative 2x into a negative 6x, I have to take the top equation times 3. If I want to change the bottom equation 3x into a positive 6x, I have to multiply the bottom equation by positive 2. And this is going to give me two brand new equations. So let's write down our two brand new equations. If I take everything in the top equation times 3, I would get negative 6x plus 15y equals negative 3. If I take everything in the bottom equation times 2, I would get positive 6x plus 4y equals 22. If I did everything right, I should be able to add these equations together and something would eliminate. And if you notice, negative 6x and a positive 6x adds up to 0, so that does eliminate. 15y and 4y would give you 19y. If you add together a negative 3 and a 22, that would give you positive 19. And that's an easy one-step equation to solve. Divide both sides by 19. So when I do that, I would get y equals 1. I'm halfway done. Now what I would like to do is figure out what x is. So I need to substitute y equals 1 into one of those two. I would go back to the original equation. And you pick whichever one you think looks easier. I kind of think the bottom one looks easier because there's no negatives in there. So I'm going to plug y equals 1 into the bottom equation. So my bottom equation is going to be 3x plus 2. Instead of times y, it's going to be times 1 equals 11. And let's solve that two-step equation. So I'm going to have 3x plus 2 equals 11. I think you can solve this two-step equation. Subtract 2 from both sides. And so I would have 3x equals 9. And then if I divide both sides by 3, x is going to be equal to positive 3. Remember that I am mathematically solving where these two lines would intersect if I graphed them. So that's why I think it's important to realize that our answer is a coordinate point, and so I would list my answer as the ordered pair 3, 1. And it's worth noting that when you're using the elimination method, this is the hardest it can get. I had to multiply both equations by something in order to make things eliminate.